Hello everyone, my name is Florian Obermüller and today I will talk about LitterBox, a linter for Scratch programs. Scratch is a very popular block-based programming language for beginners. Here we have a typical program from a beginner's course. The fish has to evade the sea creatures and try to touch the star to gain points, but touching the star doesn't increase the score. Touching the sea creatures works and the program ends. When we look at the fish, the code seems fine. He always goes to the mouse pointer and points towards the star. In the star, the code also seems to be fine, as the score is reset, and if the fish is touched, the score is increased, and then the star goes to a random position. If students have problems with their programs and they don't know how to fix them, they have to debug the program. But when they are still at the beginning of their studies, they may find debugging hard. They will need help. Also, teachers may have to help multiple students with the same problem at once. So the teachers also could use help to better support the students. To provide this help, we created LitterBox. LitterBox is a linter that can detect smells and bug patterns in Scratch projects. Smells are bad code practices, and bug patterns are idioms of defective code. To analyze the project, LitterBox parses them to abstract syntax trees and then looks for specific combinations of blocks inside the tree. If they are there, they will be flagged in the script so that they can be identified easier. And then LitterBox also gives hints why the bug pattern is there and how to remove it. From this, learners can try to avoid them in the future. In this way, LitterBox can currently detect 38 bug patterns and 30 smells. To be easily accessible, LitterBox has a web front end. There are two ways to provide Scratch projects to the web front end. One is to upload SB3 files that were downloaded from the Scratch website. The other one is providing the project's URL by inserting the project's ID. We take the project ID from our project and insert it here. Now we have the results. And the project has a missing loop bug pattern in the sprite star. The event is only checked once and then the script ends. So to check the event multiple times, the block has to be encapsulated in a forever block. When we apply this hint to our project and use a forever here, it is working and the score increases when the star is touched by the fish. As another example, let's have a look how LitterBox can be used to upload project files. Here we have a project where the rocket has to land on the moon and try to avoid the asteroid, but the landing on the moon doesn't work as the rocket never stops. The code in the rocket seems to be fine. The script waits until the distance to the moon is 0 and it is reached. Then it greets the moon, lands on it, and stops the whole project. So now we have to download the SB3 file to our computer and then upload it to the LitterBox website. Now we have the feedback. There are two position equals check bug patterns in here. This is a typical misconception that two sprites touch each other when their distance is 0. But the distance is measured between the centers, so it is really unlikely that the centers match exactly. So the hint is that we should remove the equals check and instead use an approximation with less than or one of the touching blocks in the sensing toolbox. The same holds true for the distance check in the rocket and the asteroid. And we have two empty sprite code smells, but since the Earth and Moon are empty on purpose, we can disregard this. Here we can see another thing, that the position equals check bug pattern has a very high severity, whereas the empty sprite smell has very low severity. Let's assume we want to see the hint directly in Scratch. For this we can download an annotated version of the project here and then upload it directly to Scratch. Here we see the hints for the empty sprite smells, and here we have the position equals check hint. So let's remove this and put one of the touching blocks here. This one seems to be fitting the best. And the same in the asteroid, where we also take this one and set it to rocket. If we try the game now, everything works fine and the rocket stops at the moon. For teachers who want to evaluate their whole class with LitterBox, or researchers who want to use it to analyze hundreds of thousands of Scratch projects at one time, there is another way of using LitterBox. LitterBox can be called from the command line with a default Java jar call to the LitterBox jar. Then there are parameters check signaling that bug patterns and smells should be found, a path parameter to the folder containing the Scratch projects, and an output parameter for the CSV file where the results should be stored. And if we open the results CSV file, we see that most of the students did quite good, as there are many zeros and only few projects have multiple smells, like here where there are 21 smells of the same category. LitterBox also has other usages, like Scratch blocks output. This is a textual representation of Scratch code and can be used for visualization purposes, like on the web front end. LitterBox can also calculate the code metrics of Scratch projects. This works like the batch mode and calculates metrics like block count, sprite count, health difficulty, health volume, and weighted method count. For the future work, we want to create different levels of hint detail. Currently, there is only one hint for students and teachers, but younger students may need hints on a lower level, which are easier to understand. But teachers and older students will need hints which are more detailed, so they can still learn from them. Also, we want to lower the cognitive load for using the web interface so that bug patterns of the same category will be bundled together and the site will look more tidied up. LitterBox is available on GitHub. Everyone knowing Java can add their own bug pattern smells and metrics, and the website is also available online. Thank you for your attention.
So we are in the QA of our last paper of this session, LitterBox, a Linter for Scratch programs. So please provide your comments in the chat. We have the authors here. We have Nina, Gordon, and Florian here to discuss and answer your questions. So, in the meanwhile, I have a question that is, how does the tool knows which is the specification, the correct specification or the correct behavior of the program? Probably I miss it, but how does the tool, which should be the proper behavior?
The tool doesn't need specifications about what the program should do. It just is looking for things that are common mistakes, like in the example with the rocket. the student tried to estimate the distance between the rocket and the moon by checking the distance for 0. And a common mistake here is that students think that the distance is 0 when the sprites are touching one another, but the distance is 0 when the center points overlap, because this is how Scratch is implemented. So the tool is checking if there is a check for 0, and then for distance equals 0, and then assumes that the student had this misconception, and then tries to help him with, say, that he should use a touching block instead.
Okay, so that means that, for example, if we have a program made by the students correctly programming the distance, not exactly 0, but in an interval, and then we have another program that does the same, but for example, instead of 0, it assumes that the rocket should land in 1 meter. Both programs should be considered correct by the tool.
Yes, if the second is also with an interval, it should be fine.
Yes.
But if the second says it should be equal 1, it would also detect it.
Both using an interval, so both
Fine.
would be correct.
Yes.
Okay. So we have questions here. Okay, by Gregorio. Fantastic tool. I am a big fan of it. One question with the LitterBox. I mean, why did you choose that name?
So we are working on a couple of tools for analyzing Scratch programs. And as you know, the logo of Scratch is the cat, the yellow cat, which is copyrighted, so it's not included in our LitterBox website. But all our analysis tools follow this cat theme. Right? So the LitterBox tool finds poo-poo in your code, right? And we have a whisker tool, and we have a bastard tool, which is the Egyptian goddess of cats and so on. So there's this general cat theme. That's where the name comes from.
Okay, cool. Okay, we have another question by Max. Do you already have experience with using LitterBox for grading? In this sense, is your tool more useful for teachers or for learners by providing feedback for improvement?
We have never done something like auto grading with LitterBox, because the whisker tool Gordon mentioned is more suited for that, as it is automated testing tool. And we didn't have any chance to use LitterBox yet with students, as the pandemic did prevent this.
But what we have done is include LitterBox in teacher training. So we've had teachers use it. But the interaction with children so far has been limited. But we are collecting data on this. So for each issue that is reported, with a thumbs up and down, and we're hoping to collect enough data to see who it's useful for.
Okay, good. Any more questions or comments? They are very welcome. Use the chat. Here we have. What type of techniques did you use for sanitizing the data?
Depends what you mean with sanitizing which data. So, I mean, LitterBox is a static analysis tool in the same way that FindBugs tries to find issues in regular Java source code. And so the issues it reports may be false positives. And so is that maybe what you're referring to?
Let's see what Guru, do you want to elaborate a little bit on the chat? Let's see. Okay, this is what he means. Okay. Okay.
So we have done some essentially tuning on studying the things reported and then sharpening the finders in the same sense that the patterns found by FindBugs are tuned such that they minimize the amount of false positives. There's never guarantees, but then we've introduced different severities, such that things that are usually, in our experience, severe bugs have a different priority than things that more rarely are true positives.
Okay, so we still have 3 minutes, 3 minutes and a half. Is there any other question, comment? Gregorio, could you tell more about your experience with the teachers? How did they find the tool? Did they report any problems? Do they understand all the cases? Because you mentioned that you were using the tool for training teachers.
Well, so we have, what we did was provide teachers with hints generated by LitterBox, and we asked, so essentially it's an ongoing experiment where we're looking at how teachers grade student programs if they have no input versus how they grade them if they have input from LitterBox. And we saw some differences in the efficiency and effectiveness in how many incorrect solutions they can find and how quick they are to providing feedback to their students. But this was essentially a filtered data set of which hints we want to show for which particular bugs. So I don't think we can say anything about the general impression they have when using the website. Do you know anything about that, Florian?
No, not really. But there were just 2 or 3 students that used the website that I know of, and they found it easy to use, but there wasn't much else feedback.
Okay, we have another question here by Max. How do litters found related to smells that could be found in text-based programming?
Some of the finders for the smells are exact so copies that can be used for Scratch, and some others are Scratch specific, so bug patterns that relate to painting on the backdrop, which is very specific to Scratch, can only be there, but something like the check for what was it? Checking for bad naming so that the sprites have names without meaning is something that can be seen in other linters for other languages as well.
Okay, we have another question here by Shane. If we don't have enough time to answer it, probably you want to go to the discussion room or either answer in the chat. The question is, have you considered extending your technique to analyzing APP Inventor programs?
So we have certainly considered it. The tricky bit is that the way programs are represented and the actual semantics are very different between App Inventor programs and Scratch programs. Right? You have the concept of a stage and sprites and so on in Scratch, and many of the finders and the implementation are specific to that. So I think if you want to do the same thing for App Inventor,